So we're now continuing on with our coverage of the flowable class operators and how they can be used to enforce back pressure. And this is case study ex2. This case study is different from case study ex1 that we just looked at in that we now have back pressure aware publishers and subscribers. And they're generating events at the appropriate rate because they're aware of back pressure, and they also run in different scheduler contexts, but they're aware of the rate at which things can be dealt with. As before, you can find this in my live lessons GitHub repository in the ex2 project in the reactive flowable folder. So we're now in the IntelliJ project for case study ex2 for the flowables. Let's go ahead and take a look at that. This particular example has some things in common with case study ex1, but as I mentioned before, the publisher and subscriber are back pressure aware this time. As before, we have a pending item count that keeps track of how many items are pending, which is an atomic integer. And we use an atomic integer because this is shared between the publisher and the subscriber, and they're running in different scheduling contexts. Once again, we parse the command line arguments, and then we go ahead and print out how many items we're going to be dealing with. And this time, we're going to do things a little differently. We're going to have something called a back pressure subscriber. And we'll take a look at the implementation of the back pressure subscriber in just a moment. But that's going to take the pending item count atomic integer, and it's also going to take the request size. So you can determine based on command line parameters what the request size should be. And the request size is what the subscriber uses to request the publisher to send it. It says, please send me a tranche of requests of request size. It processes them, and then after those have been processed, it then makes a request for the next chunk, the next tranche of that size. So now we've got kind of this flow control-like window between the publisher and subscriber so that the publisher doesn't generate events faster than the subscriber can keep up. And we're also going to keep track of all the disposables. We only have one, but we're going to put them in something called a composite disposable. So we can delete them all at one fell swoop. So here's the main flowable flow or pipeline in the program. It does look a bit similar to what we had before. We say publish random integers, and then we have scheduler new thread. So it's going to run this in the background. This looks similar to what we had before, but it's not identical. We're then going to check for primality. That is pretty much identical to what we had before in case study ex1. And then we're going to go ahead and use the blocking subscriber to set things in motion. So this is blocking subscribe. This is the method that you get from Flowable. And we're going to pass in the back pressure aware subscriber here to this. And you'll see how that works. So let's start by taking a look at publish random integers. And you can see it runs in a background thread. This approach looks quite a bit like the one we did before in case study ex1 with a huge important difference. It uses Flowable generate instead of Flowable create. And Flowable generate is going to take a back pressure aware emitter. So we're going to make an emitter that's back pressure aware. We'll look at that in just a moment. We have the same error handling mechanism we did before, and we also subscribe this whole Flowable chain to run on the given scheduler. So that'll run in either the single threaded scheduler or the computation scheduler. But what I really want to do here is take a look at the back pressure emitters make emitter factory method. So let's go look at that. So this method, as you can see, takes a count, the number of items to publish, the max value, the biggest value to publish, up to the biggest value to publish, randomly, and an atomic integer that keeps track of how many items are pending. We make a new random number generator, and then we return a consumer to an emitter. And this consumer is then held by the RxJava framework, and whenever a request is made, it goes ahead and calls this emitter to do the work. And you can see what the emitter does. So this emitter is going to check to see if we've reached the total count. S integers emitted is a static value that starts at 0, and every time we increment it by 1, we check to see if we've exceeded the count. As long as we have not exceeded the count, we generate the next random integer up to the max value. We increment the pending item count. We publish stuff periodically. And then we go ahead and publish the next item. So we create a random item, and then we emit it. And so this, every time the framework needs to get more data, it calls this the right number of times, the request size number of times, and it'll keep emitting either until it's emitted count values or we're done, and in that case, we go ahead and return the on-complete result saying we're finished, which again is kind of like end of file in a way. So that's the emitter, and this is really cool because this comes back as a consumer that can be held by the underlying theFlowable implementation as the parameter that's passed to generate. So the generate method gets back this consumer, and then it can call it as requested by the subscriber to generate other events. So that's what the generator looks like. So this is a little different from what we saw before because we don't have a back pressure strategy because the publisher and subscriber are back pressure aware this time, and they're going to work together to generate events at a rate the subscriber can conceivably keep up with. So let's now pop back up a little bit here, and we will see flat map, check for primality. This is identical to what we had before. It emits a number, runs it in whatever scheduler we provide here, which will either be single or computation, just like case study ex1. And then we check to see if the number is prime. This, again, is identical to what we did before. We just come in here, make a new record with the prime candidate and the result of calling the isPrime method, which just checks to see if the number is prime, returning 0 if it's prime, and the smallest factor if it's not prime. So the last piece of the puzzle here I want to focus on is the blocking subscribe terminal operation, which gets an instance of the subscriber. So the subscriber, as you can see, is this back pressure subscriber. So let's go take a look at back pressure subscriber. Back pressure subscriber is a subscriber. This is what comes actually from the Java 9 Flowable API, the subscriber interface, and it's parameterized to return prime utils result objects, which are just those records that keep track of the prime candidate and the result of calling isPrime. And we have a couple of fields here. We have the pending count field that's shared between the publisher and subscriber. We have this very interesting field called mSubscription, which is of type subscription. And this is what will be passed from the publisher back to the subscriber when the subscription is first made. So that's the way that a back pressure aware subscriber can indicate to a back pressure aware publisher how much can be published in one fell swoop. We have some other things to keep track if we've been disposed, and we also keep track of the number of items to request every time we are going to basically request another tranche of data from the publisher. And we keep track of the number of items processed since the last request, and you'll see how that gets used. And we also keep track of the number of items that are processed in general. The constructor just initializes a bunch of fields. Here's the onSubscribe hook method. This is the hook method the publisher calls back when the subscriber first subscribes to it. So when we call blocking subscribe, which we called back in the kind of the driver program, the ex2.java file, that is going to trigger, that subscription request will trigger the publisher to call back on the subscriber and say, here's the subscription object you should use to tell me how much data to send you without worrying about you running out of resources, subscriber. And you can see what we do here is we stash this away for later use, and then we tell the subscription object, please send me up to m request size on next requests before I have to ask for some more. And that can be set to whatever you want. I think I set it to 5 or 10 or something like that by default. So let's take a look now at the various hook methods in this subscriber. These are what are going to be called back by the framework as the data flows through the system. So we'll look primarily at onNext, because that's the one that is used by the publisher to feed events to the subscriber. You can see that every so often we're going to print some diagnostics indicating the results of the prime number checking. That's just like we did before for case study ex1. But here's where things get interesting. So what we're going to do after we've kind of printed out diagnostics if necessary, we're then going to check to see if we've consumed all of the items in this requested tranche. So remember, we're requesting these chunks, and let's say for sake of argument that the value is, let's see, what is the number of requests we give here? I guess it's set here by the back pressure subscriber. And if we want to find out what that is, we come over here to options, and you can see the request size is integer max value by default. So by default, we're just going to blast all the items through. But we can override that on the command line to give a different value, which would most likely be a lot smaller. So come down here. Here's what happens. We keep track of the number of items processed since the last time we called request. So that starts out with 0. And every time through, we increment it by 1. And as long as we haven't hit the request size, we just keep going. When this value hits the request size, that means we've processed all the items that we were supposed to get from the publisher. So it's not going to send us any more items until we request another tranche. So what we do here is we come in when we hit that value, and we request the next tranche size number of items. Now, if this indeed is set to integer max value, we'll never get there. But if it's set to a much smaller number, which we can do on the command line, then every so often we're going to have to request the next tranche of items. And then we're going to go ahead and reset the counter of the number of items processed since the last request. So this is basically how we manage the window, this window of values that are being sent from publisher to subscriber. Whenever we reach the window size, whenever we've consumed all the items that we requested, we then ask for the next chunk or tranche. And you can see that on error and on complete just print some diagnostic information. So let's go ahead and run the program. And you can see here that we're going to turn on debugging. We're going to have 1,000 items. We're going to have actually the request size is going to be 100. We're going to print every 100 items. And I have to remember what some of these options do. Let's go take a look. Let's see what the options do. What's the B option? Whoops. Looks like B is not needed. So we can get rid of B. And I think we can also get rid of, take a look at that again. We can get rid of B. And I think we can get rid of O as well. That's left over from the other example. All right, so let's go ahead and run this code and see what happens. So again, in this case, remember that the publisher is not just blasting data out as quickly as it can. It's sending things in chunks. And here you can see what happens. You can see there's a lot of interleaving going on, which is what we want. We're going to send 1,000 items. Here's the publisher thread, and you can see it's publishing items, and it's keeping track of how many are pending. Every so often, after we process 100 items, the subscriber requests the next tranche. So you can see that subscriber requests the next tranche. Then the publisher sends a bunch more stuff. The subscriber will deal with the results. So there's much more interleaving here. If you recall the results from the ex1 case study where there was no back pressure aware publisher and subscriber, we generated tons of data in one thread, and then the subscriber handled it as best it could after most of the data was generated. And that's why we had to buffer it if we didn't want to lose events. In this case, we're basically kind of going back and forth where the publisher sends a bunch of data, the subscriber processes it, then it asks for the next chunk of data, the publisher sends the next chunk of data, the subscriber processes it, asks for the next chunk, and so on and so forth. So these results are interleaved in a much more effective way, and so you don't run into the problem that we had with case study ex1 where you could exceed the resources, the memory resources, the processor resources, by having a fast publisher send data more rapidly than the poor subscriber can keep up with it. And indeed, as you can see here, we completed 1,000 prime number checks, which is exactly what we want. So nothing was lost, and we were able to consume or conserve the resources more effectively in this approach. So that's the end of case study ex2. You should now have a much better understanding of how to write back pressure aware publishers and subscribers.